Welcome you all friends. I am Professor Mohammad Tariq, working in the Department of Economics at AMU Aligarh. In the last lecture, we had talked about Capm capital asset pricing model. Capital asset pricing model. We'll extend the same lecture today and try to go for some mathematical derivation in order to reach at certain definite conclusion, certain definite results. So under CAPM, what did we observe? That the investment should be done in a single efficient fund. Single efficient risky fund. The investment should be done in single efficient risky fund along with a risk free fund. Risk free fund. And this constitutes the market portfolio. This will constitute this market portfolio. Clear? Now, this can be shown with the help of a diagram also in this R bar sigma plane. We would like to explain something with this diagram. So let us first draw the diagram in the R sigma plane. This is mean rate of return of an asset, and this is standard deviation of the asset, which talks about this risk factor. Now this we can draw a line which like this, and this starts with this. So combination RF. Let me draw first this line. Let this be denoted by M. So this line we call it as the capital market line. This is a combination of two assets. One, the risk free, which so this line starts with this point RF, where value of sigma is equal to 0, the risk factor is equal to 0, and this line moves in the upward direction where the portfolio, and this portfolio is called as the market portfolio. This is called M point. M is called as market portfolio. So it's a combination of this market portfolio and the risk free asset. So this is this line is called as capital market line. Now what is this capital market line? This shows the positive relationship between R bar and sigma. As the risk increases, what does it show? As the risk increases, the mean rate of return should also increase. So this is, as the risk increases, the mean rate of return should also increase for any efficient portfolio. For any efficient portfolio. This line is also called as price line. We also call it as the capital market line. This is also called as the price line. Why do we call it as a price line? So, because the prices should adjust to along this line. The prices should adjust along this line. The prices should adjust along this line. The efficient assets for efficient assets. The prices should adjust along this line for efficient assets. This is called as price line because it should adjust along this line. If there is any deviation, it should adjust along this line. Then for the efficient assets. Now, what about the equation of this line? This is a straight line passing through this point. So the standard form of this type of equation is y is equal to a plus bx. If we are drawing this in the x and y plane, the graph is in the, sorry, y is equal to a plus bx if the graph is in the x and y plane. Now, the similar logic, this can be written like this. This r bar, the mean rate of return on asset, this should be equal to a, the intercept on the y-axis, this is rf plus b into sigma. Now, we have to find out the value of b, which is what? Which is the slope of price line or the capital market line. B is the slope of price line or the capital market line. This slope we can draw like this. If you draw a line from here and here, what is this distance? The slope is nothing but this is equal to tan theta value. And what is this tan theta? Slope, which is equal to tan theta value. This is equal to perpendicular upon base. So this distance is equal to mn divided, so this distance is equal to mn divided by rfn. So what is this mn? Mn is nothing but this is equal to rm bar minus rf divided by sigma m, it's rfn. So this equation, finally this can be written as rf plus rm bar minus, this is the mean rate of return of market assets, the standard deviation of market asset into sigma, the overall standard deviation of the asset. So this is the equation for this. So what is this? This b factor, the slope of the line, this also shows that price of risk. What does this sigma indicate? Sigma indicate the risk factor. So if this risk factor sigma increases by 1 unit, what will be its impact on R bar? What will be its impact on R bar? The average rate of return of an asset. So this is called as, sigma is called as price of risk. Yeah. So this is all capital market line. This we can understand with the help of one hypothetical example. Suppose there is a security whose initial price is 0. This is rupees 875, and after one time period the price is equal to rupees 1000. Clear? Now sigma r, the risk of on asset is 40%. This is a hypothetical example, and the RF, this is 10%. This RF is 10%. Now, what is expected rate of return on market portfolio? Expected rate of return on market portfolio. Expected rate of return on market portfolio, RM bar Suppose this is equal to 17% with sigma m is equal to 12%. Sigma m is equal to 12%. So what is the mean rate of return? The mean rate of return is equal to RF plus Rm bar minus Rf upon sigma m into sigma. The mean rate of return. What is this RF? 10%. This is equal to 0.10. Rm bar is 0.17%, 0.17 minus 0.10 upon sigma 0.12 into sigma r is equal to 0.40. If you go for the calculation, if you do this, this is equal to 0.10 plus 0.07 upon 0.12 into 0.40. This comes out to be 0.33, or what you may call it, we may call it as 33% with this formula. If we go by the simple definition of this, the rate of return, simple definition of rate of return, which is R, this is equal to x1 upon x0 minus 1. So this comes out to be 1000 rupees upon 175 minus 1, and this comes out to be in percentage of 14%. So this is higher than this in this case. So this expected rate of return for market portfolio can easily be calculated by using this formula. Clear? So this formula can easily be applied. Now the basic question about the pricing line, the basic question, or what we may call it as the limitation of this that comes before this capital market line or the price line, is that it talks about the average return of portfolio. It talks about the average return of portfolio. And what is that portfolio? The efficient portfolio. Average return of this efficient portfolio. But it does not show what will be the expected rate of return of an individual asset. Expected return on individual asset. It fails to explain this expected return on individual asset, an asset. Okay? Or the relationship on this expected return on individual asset to individual asset risk. Asset risk. The relationship. This relationship is not being explained. The relation is been, or what we may call it as the relation Ri bar and sigma I. This is not being explained under this. Clear? So this can also be explained by making certain manipulations or using the help of some mathematics. And this, under this capital asset pricing model, under this CAPM, we not only talk about this, the average return for the efficient portfolio. We are also in a position to say something about this, the average return on individual portfolio and the risk on individual portfolio. And how do we do this? This is the basic question. So for this, we write down another equation like this equation we write down Ri minus Rf. This is equal to beta I where beta I is equal to sigma Im upon sigma m square. This, what is this? The average return on ith asset, and this is the return on risk-free asset. This is the average return on market asset, and this is the return on risk-free asset. What does the difference? What is this beta I? Beta I is nothing but this is the covariance between ith assets and the market asset divided by the variance of the market asset. Yeah. What does this term show? What does this entire term Ri bar minus Rf shows? Ri bar minus Rf, it shows the excess return on ith asset, because this is the excess with respect to the fixed asset. Risk-free asset, not the fixed asset. This is the risk-free asset. Sorry. Now Rm bar minus Rf, this is the excess return on the market asset with respect to this risk-free asset. So this, in other words, we can say that this is the premium on ith asset, and this we can call it as the premium on market assets. So beta will be defined as the beta. We will talk about this beta term later on when we completed the proof for this equation. So we go for the proof of this equation. How do we get this? Suppose an investor invests certain proportion, the weight Wi alpha, in the ith asset, and 1 minus alpha is being invested in the market asset. Clear? So what is this? This is Wi. This you may call it as W1 or W2, where two assets are. One is the ith asset and the second one is the market asset. Now what about the mean rate of return on this? So the mean rate of return on this R alpha bar R bar alpha, this will be equal to alpha Ri bar plus weighted average 1 minus alpha this is 1 minus alpha into Rm bar, and the standard deviation of rate of return, which we denoted by sigma alpha, this will be equal to, I'm talking about the standard deviation, so this will be the square root of variance alpha square sigma I square plus twice alpha 1 minus alpha sigma Im. Sigma Im is what? This is covariance term. 1 minus alpha square sigma m square root being denoted by this 1 by 2. Clear? So this is the standard deviation. Now what do you find in both these equations? In if we talk about as alpha varies, if there is change in the alpha varies, the the values between this r sigma plane, this can be traced out to a curve. This will be a curve in the r sigma plane. Clear? So if alpha is equal to, so as alpha varies, the r sigma plane, the value can be, we can have as a curve in the r sigma plane. Now if alpha is equal to 0, the entire investment, the entire market portfolio, the entire investment is in the market asset, entire in the market asset, and this uh, this curve must be tangent to the capital market line, and the curve, this efficient efficiency curve must be tangent to market price line. This we can show with this diagram. Like this. So what is this? This is the investment in the ith asset. This is market asset. Clear? So the tangency required, the slope of the curve is, slope of curve is equal to slope of capital market line at M. So at M it should be the tangent. The slope of curve, this curve, efficiency curve, it should be equal to the market price line. Clear? Now, with the help of this, we try to find this the slope factor. How this slope is there? Slope is nothing but for any graph, this in the y-x plane, whatsoever be the graph, like this or this or this, whatsoever be the graph, the slope is being given by dy by dx. It shows the rate of change in y due to a change in x, a small amount of change in x. So similarly, we can find out the slope for this equation, this line, and the slope for this line, and try to reach at certain conclusion. Clear? So what is this? Again, let me rewrite this equation. The next page. R bar alpha, this is equal to alpha Ri bar plus 1 minus alpha Rn bar. So this d r bar alpha upon d alpha, the slope of this line, this will be equal to Ri minus, if we take this, so this can be written as Rm bar. Let me explain. Rate of change in mean rate of return due to change in alpha. Similarly, let me write down sigma alpha. Again, the equation for this sigma alpha, this is equal to alpha square sigma I square plus twice alpha 1 minus alpha sigma im plus so d sigma alpha upon d alpha. Again we apply the chain rule over here for differentiating this equation, and if we apply this chain rule, I'm writing down the result. The result will be, if we apply this chain rule, this will be equal to sigma square to sigma I half minus 1 into twice alpha plus 1 minus twice 1 minus 2 alpha into sigma im plus twice into alpha minus 1 sigma m square. Sorry, this will be 1 by 2 into this. So this 1 by 2 into, we take this term as first and take 2 as common from here. So if we take 2 as common, this will be alpha sigma I square plus 1 minus 2 alpha sigma im plus alpha minus 1 sigma m square. This half minus 1 is equal to half minus 1 is equal to minus 1. So this can be written in the denominator with a positive sign. So this will be equal to alpha square sigma I square plus now this 2 gets cancelled out. So what is left is sigma I square 1 minus 2 alpha sigma im plus alpha minus 1. What is this term in the denominator? This term in the denominator is nothing but this is sigma alpha. So this is equal to sigma alpha. So what is this final result? D sigma alpha upon d alpha is equal to this much. Clear? Now, when alpha is equal to 0, the entire assets become the market asset. And this sigma alpha can be, for alpha is equal to 0, it can be replaced by sigma m. So what about the value of d sigma alpha upon d alpha when alpha is equal to 0? So this term will become 0. This will be sigma im plus 0 minus 1. So this will be minus sigma m square upon, now sigma alpha to be replaced by sigma m when alpha is equal to 0. Clear? So this again I'm writing down this equation, this dr alpha upon d sigma alpha, dr alpha upon, this is another equation that we have derived. Now this and this, 1 and 2 equation from here. So this can be rewritten as dr bar alpha, divide this both numerator as well as denominator by d alpha by d alpha. We divide both numerator as well as denominator by d alpha. So what is this term? The numerator term is equal to this one from equation 1. So Ri minus Rm bar, this what dr alpha upon d sigma alpha, this can be written as Ri minus Rm bar, this divided by sigma Im minus sigma m square by sigma m. So this sigma m will go in the numerator. Clear? So this is this slope. Now this slope, what I told you earlier, this here, that the slope of the curve must be equal to the slope of market line at m. The two slopes must be equal. The slope of this market line, what about the slope of this market line? The slope of this market line is here, this Rm bar minus Rf upon sigma m. So these two slopes should be equal. So this should be equal to Rm bar minus Rf upon sigma m. These two slopes. This clear? So these two slopes should be Rm bar minus Rf upon sigma 1. This should be equal. Now we rewrite this equation again on the next page.